I want to show you the AWS backbone behind the web app that I've been working on. It's a dream journal app. You can record your dreams by typing or just using your voice. Then it uses AI to interpret them, generate images, and even determine patterns across multiple dreams. Behind the scenes, it's powered by 13 different AWS services. I'll walk you through how each one of these fits into the flow of my web application. Here we are on the website and it's called oneiras.com. I'm using AWS Amplify to host and deploy the app. AWS Amplify allows you to use TypeScript for your front end, back end, and even infrastructure code. It abstracts a lot of things for you. The reason I chose AWS Amplify in the first place was the user management. AWS Amplify abstracts this for you by using AWS Cognito. If I click sign up with Google, for example, I can sign up with one of my email accounts. It looks like I was already signed up with this one. What happened was AWS Amplify made the request to AWS Cognito to create or authenticate, in this case, this user for me. If you look at what's called a user pool, that's where all of your users are stored, we can see that the email I've used was used to create this user. Once you're logged in, you're displayed with the list of dreams, which in my case, just one. Whenever you click create new dream, you can give it a title, which we can call demo 2. You can either write the description or record the audio. We're gonna write the description, and then you can add a real life context just to make sure AI can use it in its interpretations to make it somewhat more accurate. We're gonna add the description, add the real life context. If you wanted to, you could add the sleep times and click save dream. This dream is gonna be saved into a DynamoDB table. That's what we use for storage. It's a highly scalable and highly available NoSQL database. You would use DynamoDB typically for non-file type data. Whenever you create a dream, we record it in the database so we don't lose it. I mentioned earlier that AWS Amplify abstracts AppSync for you, but it still allows you to execute GraphQL queries. You can define them in the data resource file. We have a send create dream query, and then we have a handler attached to it. All this Lambda function does is sends a message to an SQS queue called create dream. If we go to AWS and go to SQS, we can go to the create dream one. All it is just a place to which you can put your messages. Then you can set up SQS queue as one of the Lambda triggers. If you scroll down a bit, go to Lambda triggers, we see that this SQS queue triggers interpret dream Lambda function. When you put a message on this queue, this interpret dream Lambda will get triggered and will be processing this message based on the code that is in it. We have configured what's called a dead letter queue. What we can do is set up alarms on this queue so we get notified when something failed. Once we fix whatever was wrong with it, we can what's called redrive this message to the source queue and see if it succeeds then. Most of my app is working by the same principle. Have another Lambda do something, submit another SQS message. Both of these things are scaled automatically, so you don't need to worry about doing any of this manually. If you're curious, I have a lot of Lambdas, but we can look at the interpret dream one, which is kind of misnamed right now because it's more of an orchestrator. Yes, it does interpret the dream, but it also sends SQS messages to other queues, for example, generating dream images, generating dream embeddings, so we could later provide you with patterns and search abilities, etc. If we go to the interpret dream Lambda, we have the SQS trigger. Now, we talked about storage with DynamoDB, but sometimes we also need to store files. For that, we are using S3. You would typically use it for file type object, for example, images, as well as when you decide to record your dream via audio instead of just by text. Now let's talk about subscriptions. I'm using Stripe for managing subscriptions, and whenever somebody makes a payment to Stripe to sign up for the premium plan of my web application, I want to get notified about it right away to make sure that I can upgrade them to the premium plan. You can configure what's called a webhook. For that, we're using API Gateway. We have a Stripe webhook API, which is a post method. Whenever Stripe calls this endpoint, this Lambda function gets triggered and your profile gets updated, making sure that you're a premium user now. Now let's look at all the services that keep this app production ready. First, let's go to Route 53. Route 53 is how you can buy and manage the custom domain in AWS. First, you would need a hosted zone, which would match your domain name. Here you can define all different records that are typically used for either setting up CNAMEs, so you have, for example, beta.oneras.com, or you can configure these records to make sure that you can set up emails working with your email provider, so whenever somebody emails you at contact@oneras.com, they would actually come to your email. If you just bought the domain, it would not be secure. It would always show to the users that this website is not using HTTPS, it's just using HTTP, and this connection is not secure. What would you do to fix it? You're correct, we need a certificate. We would go to Certificate Manager, then we would go here and see that it is attached to our domain, so our website is using the secure HTTPS connection. Another thing I'm using to keep things secure is the parameter store inside the Systems Manager. I can store my third-party API keys, so I don't have to hard code them in my app or use environment variables for that, because environment variables get exposed during the build time and we want to avoid that. If you wanted to create a secure string parameter, you would just click create parameter, give it a path. That way you could group related keys together. Whenever you configure permissions for who can access that, you can just give it based on the path instead of individual keys. Then you would choose secure string. You can keep this KMS key source as default, provide the value, and click create parameter. Now, I did mention that not everybody can access these keys. How do we manage who can or who cannot? Well, for that we're using IAM. By default, AWS services don't have access to talk to each other or to retrieve information that they need. You can configure, for example, for your Lambda to have access to read from the DynamoDB table or to get access to the parameters, stores certain API keys or certain path of the API keys. Next thing we'll discuss is CloudWatch alarms. CloudWatch alarms let us get notified when something failed within your application. Obviously, you don't want to just sit here 24/7 and monitor them. What you can do is configure an action and say whenever alarm gets triggered, send a message to this topic. This topic is what's called an SNS topic. Typically, you can think of SNS topic more of like an SQS queue, except when you want to deliver your message to multiple consumers instead of just one. In our case, we are using it for emails. We have a subscription that whenever a message gets on this SNS topic, it's gonna email me about it. Now, the last thing I use is CloudWatch logs. We would go to log insights. By default, each Lambda logs to a different log group. We're just gonna select all of them, click run query, and we will see that 7 records are shown. But what's cool is you can see that there is an error. The key is to always log the errors so you're not flying blind whenever something actually does go wrong. And that's the full picture. These are the 13 AWS services working together to power a serverless Dream Journal web app. Feel free to go on oneras.com to sign up and try it yourself. And if you want me to dive deep into any of these AWS services, comment under this video. Otherwise, I will see you in the next one.